So good morning to all. So today I am going to discuss about a question here from the electric charges and fields. Derive an expression for the intensity of electric field at a point on the axial line of an electric dipole. So before going to discuss this one, we have to discuss about what is an electric dipole and what is the intensity of the electric field. What is the definitions of these two here. So let me explain first of all what is the intensity of the electric field. So suppose let us consider here at a point O there is a positive charge. There is a positive charge, I am taking it as the plus Q charge. So due to this charge there is an electric field around this one, positive charge. At a point P here, which is at a distance R, I want to find out what is the strength of this positive charge, or else what is the intensity of this positive charge at this point. So to calculate the strength or intensity of this positive charge at the point P, which is at a distance R from the positive charge, I am assuming a unit positive charge at a point P. Since it is a positive charge, this is also a positive charge, there is a force of repulsion here. Let us consider F is the force of repulsion. And we know that from the Coulomb's law here, the force of attraction or repulsion between the two positive charge is given as F is equal to 1 by 4 pi epsilon naught Q into Q naught by the distance between the two charges is nothing but R square. And the intensity of positive charge at P, intensity is nothing but strength of the positive charge at P, is given as E is equal to F by unit positive charge. Means the force experienced by the unit positive charge is called as the intensity of the charge at point P. So therefore, after substituting F value here, finally we will get E is equal to 1 by 4 pi epsilon naught Q by R square. So this is the formula for intensity of electric field. So due to the positive charge, intensity of the electric field is away from the positive charge. The direction of the electric field is away from the positive charge. And for negative charge here, suppose if I consider at point O here, I am taking a negative charge, and at a point P, I am taking a positive charge, test charge. This one is nothing but a test charge at a distance of R. There is a force of attraction. So in the direction of the force, the electric intensity of the electric field is there. So therefore, for the negative charge, intensity of the electric field is towards the negative charge, and for the positive charge, intensity of the electric field is away from the positive charge. So these are the two things you have to remember here. For the positive charge, away, and for the negative charge, intensity is towards. Now let us see what is an electric dipole. Electric dipole is nothing but two charges of same magnitude. If I consider here minus Q and plus Q, two charges of same magnitude. Suppose this one is a minus 1 coulomb and this one is a plus 1 coulomb. Plus and minus indicates the polarity. Two charges of the same magnitude. Magnitude means here 1 coulomb and 1 coulomb, separated by a small distance. For example, let us consider 2a is a small distance between these two charges here. The two charges having the same magnitude separated by a small distance is called as an electric dipole. This is called as an electric dipole, constitutes an electric dipole. So to measure the effect of the electric dipole, there is a physical quantity which is called as electric dipole moment, which is denoted by P bar. So P is equal to, if I take the magnitude here, what is P bar here? Electric dipole moment. Magnitude of any one of the charge into distance between the two charges. This is a formula to calculate the electric dipole moment. electric dipole moment. It is a vector quantity. It is a vector quantity, so therefore what will be the direction? The direction it is from the negative charge to positive charge. This is the direction of the electric dipole moment, and this is the formula. So here you have to remember the 3 points here. If I am taking a positive charge, electric field intensity, it is away from the positive charge. The direction of the electric field is away from the positive charge, and for negative charge, the direction of the electric field is towards the negative charge. Electric dipole moment, P bar is equal to Q into 2A. That is the formula, and the direction of the electric dipole moment is always from negative charge to positive charge. Is it clear? Okay. Now let us discuss about what is the intensity of the electric dipole moment on the axial line. So let us discuss what is an axial line first of all. So here I am taking the 2 points. Let us consider this is the A point and this one indicates the B point. At A point I am taking the negative charge. At B point I am taking the positive charge, and both the charges are separated by a small distance 2A. And let us consider O is the center of the electric dipole. O is the center means from AO is nothing but A value and OB value is A. Means the distance between the two charges is A plus A to A. And the line which is passing through the electric dipole and through the center of the electric dipole is called as an axial line. So this one is an axial line. This is an imaginary line which is passing through the two charges and from the center of the electric dipole. Now here let us consider this is a point P, right? At a point P which is at a distance of, let us consider it is at a distance of R from the center of the electric dipole. It means that from the positive charge what will be the distance of the P point here? The distance of the P point is nothing but R minus A, and from the negative charge the P point it is at a distance of R plus A from the diagram. So as we discussed previously here, what is the electric field intensity at a point P due to the positive charge? Okay, here due to the positive charge, intensity of electric field at point P is given as A is equal to, I am taking it as the E1. E1 it is equal to 1 by 4 pi epsilon naught Q by, what is the formula here? Formula is nothing but E is equal to 1 by 4 pi epsilon naught Q by R square. What is R indicates here? R is the distance between the charge and the point P. Distance between the charge and the point P. So remember this one. So Q by the distance between the positive charge and the point P. The distance between the positive charge and the point P. Positive charge and the point P is nothing but R minus A. So I am writing the formula here, R minus A whole square. General formula is R square here. R indicates the distance between the charge and the point P. Right. Now here similarly, due to the negative charge, the intensity of the electric field at point P is, I am taking it as a let us consider let E2 value. E2 is equal to 1 by 4 pi epsilon naught. I am writing the magnitude, remember. So negative charge magnitude is nothing but Q by, what will be the formula? We have to take the distance between the negative charge and the point P. So what is the distance between the negative charge and the point P here? Negative charge and the point P is nothing but R plus A. Actual formula is R square. So here R plus A whole square. So if I take the directions here, even direction due to the positive charge, I already discussed this one. Due to the positive charge, electric field intensity is away from the positive charge. Means at a point P, due to the positive charge, intensity E1 is away from the positive charge, means that is along BP line. So this is along BP line. Clear? And due to the negative charge, intensity of the electric field at a point P, it is towards the negative charge. Means E2 value. This is the E2 value, intensity of the electric field. Due to the negative charge, it is towards the negative charge. Means the negative charge, it is from P to E. Means E2 value is along P to E. Now if you observe here in the diagram, at the point P there are two intensities, right? E1 due to the positive charge and E2 due to the negative charge. We want to find out what is the net electric field at the point P due to the electric dipole. Now here these two are vector quantities, and since both are in the opposite direction, so net electric field, it is equal to E1 minus E2 or E2 minus E1. So which one is correct? E2 minus E1 or E1 minus E2? Okay, let us see the formula here once again. If you see the formula here, E is equal to 1 by 4 pi epsilon naught Q by R square. In this one, what is the relation between the electric field and the R value? It is inversely proportional, R square. So what do you mean by this one? If R increases, E value decreases. If R increases, E value decreases. If R decreases, E value increases. Means for the smaller distance, electric field will be more, and for the larger distance, electric field will be less. Now similarly here, if you take here E1. E1 is the electric field due to the positive charge. So point P, it is closer to the Q charge. Means the electric field due to the positive charge will be greater than the electric field due to the negative charge. Means E1 is greater than E2. Are you getting? P point is nearer to the positive charge. So therefore electric field due to the positive charge will be greater. Means E1 is greater than E2. So let us calculate here what is the net electric field at the point P. So net electric field at P is given as, I am writing it as the E value, it is equal to E1 minus E2. Did you get this one? Depending upon the magnitude, E1 is greater than E2 here. E1 is greater than E2. Why it is greater means? It is inversely proportional to R square. So depending upon this equation, E1 is greater than E2. So therefore, net electric field at the point P is E1 minus E2. Okay, can you tell me what will be the direction of the net electric field here? E1 is greater than E2, no? E1 is greater than E2. So subtracting E2 value from the E1 value. So the resultant electric field direction will be in this one, in this direction, towards the right direction. Is that clear? Okay. Now here. So see the calculations. Many of the students will feel some difficulty while doing the calculations here. So here, let us see the calculations step by step. E value is equal to 1 by 4 pi epsilon naught. E1 value we have to write. So therefore Q by R minus A whole square minus 1 by 4 pi epsilon naught Q by R plus A whole square. So let us do the calculation here. So which one is common here? Q by 4 pi epsilon naught value is common. 1 by R minus A whole square minus 1 by R plus A whole square. So we have to do the calculation here. Simple calculation. E is equal to Q by 4 pi epsilon naught. LCM is R minus A whole square, R plus A whole square. So therefore here we will get mathematically R plus A whole square minus R minus A whole square. Right. Simple calculation here. Now here. So therefore E value it is equal to q by 4 pi epsilon naught r minus a into r plus a. I'm rewriting this one as the whole square because square is on both sides. For r minus a whole square, this is also r plus a whole square. So r minus a into r plus a whole square. Now a plus b whole square formula and a minus b whole square formula. A plus b whole square formula means r square plus a square minus 2ra minus of r square plus a square minus 2ra. Sorry, this one is plus 2ra and this one is minus 2ra. Now a value is equal to q by 4 pi epsilon naught. This is r square plus a square plus 2ra multiplied minus r square minus a square minus of minus plus 2ra. It is in the form of a plus b into a minus b. So therefore a plus b into a minus b means, what is the formula? A plus b into a minus b means it is nothing but a square minus b square formula. So I am using this formula here a plus b into a minus b formula means r square minus a square whole square. So here r square plus r square minus r square, a square and minus a square will get cancelled. Clear? Okay. So here let us see what are the terms we have. So therefore a value is equal to q by 4 pi epsilon naught 4ra by r square minus a square whole square. So I am rewriting this one. It is equal to 1 by 4 pi epsilon naught 2 into q into 2a into r by r square minus a square whole square. So q into 2a. What is q into 2a here? Q into 2a is nothing but electric dipole moment. So let us write the value here. In the place of q into 2a, I am writing a is equal to 1 by 4 pi epsilon naught 2 p r by r square minus a square whole square. So this is the electric field intensity at a point P. At a point P due to the electric dipole moment. Now suppose electric dipole moment is very short, means here comparing this r value it will be greater than a value. If the distance between the two charges, if it is less, very less, then r value will be greater than a value here. In that case we can neglect the a square value. So here I am taking the condition here for very short dipoles, for very short electric dipoles. R value it is greater than a, so therefore a square can be neglected. If a square neglected from this equation, therefore the a value is equal to 1 by 4 pi epsilon naught 2 p r by, I am neglecting the a square, means r square whole square. R square whole square means r power 4. So therefore r and r get cancelled here, we will get r cube. So what is the final formula for the very short electric dipole? 1 by 4 pi epsilon naught 2 p by r cube. Okay, in this one, what is the direction of the electric dipole moment now? Direction of the electric dipole moment is always from the negative charge to positive charge. So this is the direction of the electric dipole moment. What is the net electric field direction? Net electric field direction is towards right. Electric dipole moment is also towards right. It means that At any point on the axial line, the net electric field due to the electric dipole moment is always E net and P bar, both are parallel to each other. E net is parallel to P bar. What is E net here? E net indicates the net electric field due to the electric dipole moment on the axial line, and P bar indicates the electric dipole moment. Both are always parallel to each other, means along the same line, along the axial line. So thank you all.